In this tutorial, I will show how to install and run the Proteinarium command line interface tool for multi-sample protein-to-protein interaction network analysis. To install Proteinarium, navigate to the Proteinarium GitHub page by following the link displayed on the screen. Users must first install Java versions 1.8, 9, or 10 before downloading and running Proteinarium. Download the Proteinarium zip file by clicking the hyperlink. Unzip the zip file and save it in the directory of your choice. Inside the zip file, you will see 6 files, including the configuration file containing user-defined settings for running Proteinarium, Windows and Mac helper scripts, the Proteinarium jar file, and 2 example input gene lists for analysis. The example configuration and gene list files are here to help guide users in formatting their own custom input files and in running analysis along with this tutorial. Inside of the config file, users define a set of instructions for running Proteinarium. Proteinarium allows users to analyze protein-to-protein interaction networks and weighs the interacting proteins based on the number of samples that contribute to each protein in the network. Further, users can define whether samples belong in Group 1 or Group 2 to distinguish whether interacting proteins are differentially significant between case and control sample groups. Now, we will open up the configuration file in our text editor. First, you will need to specify the file names or paths to the text files containing the sample IDs and lists of associated proteins in both Group 1 and Group 2 sample groups. If you are running Proteinarium with only one gene list, as described in the documentation, you will only need to define the gene set file name for Group 1. The user must also define a project name which is used as a prefix for naming the Proteinarium output files. Optionally, users can define custom settings for running the network analysis and for generating visualization graphs. You can learn more about the various Proteinarium settings in the documentation hosted on the Proteinarium GitHub page. The max path length setting is particularly useful and tells the program how many imputed genes will be allowed for finding network connectivity between proteins in the dataset. There are a variety of additional settings available, so I recommend reading the documentation for more information. To run Proteinarium, you can follow the written instructions on the GitHub page. Open the command line via Terminal on Mac or PowerShell on Windows, and run the Mac or Windows helper script. The helper script must be saved in the same directory as the Proteinarium jar file and the configuration file. Alternatively, you can run Proteinarium by running the jar script directly by first calling java-jar. Proteinarium takes several arguments, but remember, most of the settings are defined in the config file. You can run the Proteinarium helper script with the flag -h or -help to see the available options. You can also run the script with the flag -o or -option to see the available configuration settings. Running the script with the flag -d or -default will show you the default configuration options. Once you run the Proteinarium script by defining the config file name, the analysis will begin running. The runtime depends upon the size of your dataset and on your available computing resources. The program will save and automatically display a dendrogram of samples in your dataset, grouped by similarity of associated significant proteins. You will be able to explore the protein interaction networks of individual patient clusters by generating layered protein interaction network graphs which show the weight of contributing samples on each gene in the network, but we will discuss this later. In the dendrogram, clusters that have a significant differential abundance of samples from either Group 1 or from Group 2 will be identified by cluster number labels in red text. Samples from the Group 1 file will be visualized by yellow branches, while Group 2 samples are visualized by blue branches. Experimentally speaking, these significant clusters may be case-dominated or control-dominated clusters. After viewing the dendrogram, you may want to investigate individual clusters in more detail. Proteinarium will still be running and awaiting user input on the command line. You can draw information from individual clusters using the info command, followed by the cluster ID number. For example, here we query more information about cluster 52 by entering C52. This returns a set of additional information about cluster 52, including, but not limited to, the number of samples that are in Group 1 and Group 2 respectively, the p-value indicating the significance of overabundance of samples in either Group 1 or Group 2, and the specific sample IDs in the cluster that fall into either group. In addition to viewing the sample clustering dendrogram and its associated data, you can generate a layered protein-to-protein interaction network graph. You can visualize the layered protein interaction network graph for individual clusters of interest by entering the cluster ID into the command line interface. For example, we will visualize the layered network graph for cluster 52 by entering the cluster ID. The layered graph will automatically display interacting proteins associated with samples in the cluster of interest. Proteins that are only associated with samples in group 1 are displayed in yellow, and those which are only associated with samples in group 2 would be displayed in blue. Proteins that are associated with samples in both group 1 and group 2 would be displayed in green, and proteins that are not found in any samples in the cluster of interest, but are imputed to interact with proteins that exist in the dataset, are displayed in red. The number of allowed imputed genes connecting proteins that exist in the dataset is defined in the configuration file with the option max path length, which we've set to 2. The number of samples that are associated with the gene in the network is visualized by the saturation of color, as indicated in the legend. Alternatively, you can learn more about the protein interaction networks within a single sample. Do this by entering the sample ID of the sample of interest into the command line interface. The protein interaction graph will automatically display and save to the working directory. Now we will review the files that are saved to the output directory while running Proteinarium. The output directory will be created in the directory which contains the Proteinarium tool scripts and will be created upon running the tool. Within the output directory, you will see the main Proteinarium dendrogram information text file, and layered network graph files. Additionally, if you choose to explore individual clusters or samples, directories containing output for these will be saved within the output directory. Within the output directory for an individual cluster, in addition to the layered network graph image file, you will also find the GeneSet file, which contains lists of proteins in the network and the number of samples associated with each protein. You can also view the edges of the protein interactions in the interactions text file, with associated weights which are drawn from the string protein-to-protein interaction database which powers Proteinarium. This is the end of our tutorial. We hope that you will find Proteinarium a valuable addition to your protein interaction analysis workflows. You can reach out to us with questions, comments, or suggestions by submitting an issue on our GitHub page. Thanks for watching.